Jai Hind everyone. I am Dr. Parul Verma from Applied Science and Humanities Department. Today I am going to deliver lecture on conducting polymer. This topic belongs to Unit 5 and this topic, in this lecture I am going to explain all about conducting polymers. In this lecture I am going to cover definition of conducting polymer, what are conducting polymers, then classification of conducting polymer, in which I am going to explain all the types of conducting polymer, and then I am going to explain application of conducting polymer. So as we all know that there are various kinds of polymer available in the market, and in chemistry we are actually forming various kind of polymers, but most of the polymers are insulator in nature. Only very few polymers are conducting in nature. That's why this class of polymer become a specific class, because most of the polymers are insulating in nature. That's why we are using these kind of polymer in various application due to its insulating nature. But few polymers are there which can also be used as conducting material, hence known as conducting polymer. And what is the basic application to use polymer as conducting material? Because in various devices where conducting materials are used, if we use metal as conducting material, metal has a tendency to show corrosion, metal has a tendency to show degradation. Although polymers, when used in place of conducting material, they are going to degrade at very small rate, very low rate. Also, they are very good corrosion resistance. That's why conducting polymers are important. Various conducting polymers are nowadays useful in various applications such as electrosynthesis. Its conductivity is maybe high and low, and depending upon its conductivity, it can be useful for various purposes. So let us start the topic. As we all know, the polymer which can conduct electricity, conduct electricity is known as conducting polymer. So here in this slide, two examples are given. One is polyaniline. Polyaniline is the polymer of aniline molecule. The monomer of polyaniline is aniline, and when it gets polymerized, it forms polyaniline, which is nowadays useful in making rechargeable batteries, because there is enough number of pi electrons available, which when delocalized in overall the polymeric chain, it will form a very good conducting polymer. Another example here is polypyrrole, which is formed by the polymerization of pyrrole unit, and this conducting polymer is useful in making smart windows, the windows which can change color according to the temperature and sunlight outside. So these are the examples of conducting polymer which we are using nowadays. Now, on what points, what are the properties of a conducting polymer? Why polymer become conducting in nature? So first one is polymer become conducting upon doping. It means if we dope some polymer which is already having some pi electrons in it, and we doped it, it become conducting in nature. Polymers, if are electronically charged, it means if the molecule is having positive or negative charge on it, these charges can delocalized over all the whole polymeric structure, and the polymer become conducting in nature. Another one is polymer chain can generate charge carriers. It means the charge can be carried forward to the whole chain. Next important feature is that the concentration of dopant, which we are going to add in the formation of conducting polymer, basically make these electron unpaired. If unpaired electron is available, which is very, very active, and it can delocalized over all the chain of polymer, and the polymer become conducting in nature. In the process of making of conducting polymer, polaron and bipolarons are formed. Polaron is the charge species in which one positive or one negative ion, one positive or one negative charge is there. If positive charge is there, it is known as positive polaron, and if negative charge is there, it is known as negative polaron. But if two positive or two negative charges are there, the system is then known as bipolar. Or the polymer may be conducting in nature when it is having a extended p orbital system. So overall, these are the properties to show conductivity in a polymeric structure. So there are various plastics which are polymer. They have long chain repeating structures and they become electrically conducting, and they imitate a metal. It means their conductivity is just like a metal. One example of this is emeraldine, which is polyaniline actually. Commercially, it is known as emeraldine, which is also known as synthetic metal because its conductive nature is just like a metal. So metal is a good conducting nature. Metal is having a good conducting nature, and if polymer is also having this kind of conductivity in it, it become very useful for us in a various application where conducting material is useful. One another example of conducting polymer is polyacetylene. This polyacetylene is also a conducting polymer, and it is basically a simplest conducting polymer. So when we talk about the preparation of polyacetylene, we can observe that acetylene molecule form this polyacetylene in which various pi electrons are available. Due to unsaturation remain in the molecule of polyacetylene, various pi electrons are available which can conduct electricity. So polyacetylene is the molecule in which pi electrons are available, and due to these pi electron and this extended pi orbital system, this polymer become conducting in nature. Now come to another point, classification of conducting polymer. Conducting polymer are of two types. One is intrinsically conducting polymer. Another one is extrinsically conducting polymer. What does it mean? Intrinsic conducting polymers are the polymer in which the whole polymeric chain, if A is the monomer and it is the polymer, the whole polymeric chain is conducting in nature. While in extrinsic conducting polymer, some conventional polymer mixed with some conducting material or some conducting polymer and make it conducting in nature. It means it is not a pure conducting polymer. Mixing make it conducting in nature. So intrinsic conducting polymer in which whole polymeric chain is conducting in nature, while extrinsic conducting polymer in which few parts of the chain are actually conducting, but not whole, the basic chain is not conducting in nature. The further classification of intrinsically conducting polymer. Intrinsically conducting polymer are of two types. In originally conducting polymers having conjugation pi electron, one of the class, and when these polymers are doped, it become another class which is known as doped conducting polymer. So intrinsically conducting polymer are of two types. One is conducting polymer having conjugation. It means originally the whole polymeric chain is conducting in nature. Maybe its conductivity is somewhat lower. But when these kind of this first class of polymer is getting doped with some material, the class become doped conducting polymer, and this doped conducting polymer is having high conductivity due to this doping process, and it become the another class of conducting polymer. Another class which is extrinsically conducting polymer in which we are actually mixing the conducting material. So there are two ways by which we can mix these conducting material. One is known as conducting element filled polymer. Another one is blended conducting polymer. In element filled conducting polymer, we are mixing some conducting elements, conducting compounds. In blended conducting polymer, we are going to make a blend of a conventional polymer such as PVC, polyethylene, and some conducting polymers such as polypyrrole, polyacetylene. So now we are going to study these polymer in detail. First class is intrinsically conducting polymer, and among intrinsically conducting polymer, the first class is conducting polymer having conjugated pi electrons. So as I told you just now that this acetylene molecule, when polymerized to form this polyacetylene, it is having pi bonds in it. This whole chain is having pi bond in it. And in pi bond, you all know that there are pi electrons available. And these pi electrons, when delocalized, make this polymer conducting in nature. And it is written over here that it is having conjugated pi electrons. It means alternate double bond and single bond. And due to this alternate double and single bond, the system is known as conjugated system. And here in the whole polymeric chain, the conjugation is there. So this class is known as polymers having conjugated pi electrons in it. Acetylene is one of the example. Another example is polypyrrole. In this example, we are polymerizing pyrrole unit and it will become polypyrrole. In this system, you can also observe that alternate single and double bond is available. So if this alternate single and double bond is available, this is known as conjugated pi system, and this molecule is conducting in nature due to the availability of conjugated pi system. Another important example which is useful is polythiophene, in which n number of thiophene unit converts into polythiophene. Next class is doped conducting polymer. So the class which we studied just now, when we are doping these kind of system and making compound more conducting in nature. So by the doping process, we are actually creating either positive sign or negative sign, and we are increasing the electron delocalization nature of a compound. So more good conductivity compound can be formed. So if I explain the process of doping, so this is one of the process actually in which what we are doing, we are introducing iodine molecule into polymer molecule which is already conducting in nature. Due to this iodine system, one electron is jump out from the acetylene molecule. One electron is jump out from this acetylene system. And when electron jump out with this acetylene system, a positive charge has been generated. And due to the delocalization of this positive charge, this molecule become very good conductor in nature. So here in this example, the delocalization of positive charge is shown. This doping process, in this doping process, you can see when positive charge is generated and when one double bond breaks down, double bond is the formation of one electron from both ends, and one electron is eliminated, leaving behind positive sign. Then what about another electron? This another electron become free in nature, and we can observe in this series that this electron is jumping. This electron is jumping, leaving behind delocalization of positive charge. So earlier the positive charge is here, now it is getting delocalized. This delocalization of positive charge make this compound conducting in nature and good conducting in nature. The species in which this radical ion is there, one free electron is there, because double bond is made up of two electrons. If one electron is donated or eliminated, the electron which is remain in the system is termed as radical ion. The ion is termed as radical ion. This particular species is known as polyron, which I discussed earlier also. This particular species is known as polyron. So the only electron of the double bond from which an electron was removed can move easily because it is free in nature. It is very much free in nature. So it can move very freely, and the positive charge is actually cannot move readily as compared to free electron, because free electron is very much free, while the positive charge is fixed by some electrostatic attraction to the iodide ion. Now we can observe that after doping, these polypyrrole, polythiophene, polyacetylene, the molecules which are already conducting in nature, after doping their conductivity is increased, even though they become this is the level which is showing that the conductivity of conjugated polymers, it is somewhat better than some metal also, copper, silver. So this conductivity, the conductivity of following polymer which is already doped, as is comparable to semiconductor. So if we take the example of polyacetylene, and when we dope it with the iodine molecule which we just discussed now, so doped polyacetylene is having a quality of conducting just like metal, or we can say originally it is semiconductor in nature earlier to doping, but after doping its conductivity can be comparable to metal itself. Now we are going to explain two types of doping. I am going to explain two types of doping. One is known as N-doping, another one is known as P-doping. In N-doping, reduction process occurs. In N-doping, reduction process occurs. This reduction can be done in the presence of some reducing ion. This is the example which I named it as sodium naphthaldehyde. So reduction can, N-doping, we can named it as N-doping. N-doping means reduction process. This reduction can be done by sodium naphthaldehyde like compound which is reducing agent. In this N-doping, what will happen when the polyacetylene molecule react with this kind of compound, the sodium ion, the molecule leaves sodium ion and this CHX is going to carry negative charge, and now the delocalization of negative charge makes this compound good conductor in nature. So N-doping is occurring due to this delocalization of negative charge. That's why it is known as N-doping. So if we are taking the example of, this is polythiophene, this is polythiophene. If one electron is eliminated from this polythiophene, what will happen? One positive charge occur in this system if one electron is donated, and one free radical ion is formed, and this species is known as polymer. And again, if I donate one more electron from this system, one more positive sign is formed. So one more positive sign is formed. This species is known as bipolar. This species is known as bipolar. Now you can see, if I make the whole compound here, now you can see the molecule is having two charges, and due to this positive charges, because positive charges denote deficiency of electron, these electron get shifted towards the electron gets shifted towards this positive charge. So due to this kind of polarization, due to this, one negative charge is there, because in CH negative charge is there. So due to this negative charge, another negative charge, this is known as bipolar. So what will happen, that when CHX reacts with sodium naphthaldehyde, it will form Na plus and give CH minus X plus. So when one electron is added actually, when one negative sign comes to the ring, one more electron is added, one more negative sign comes to the ring, and this structure is known as bipoleron. When this bipoleron is formed, so out of this structure, when bipoleron is formed, when this bipoleron is formed, this delocalization of charges occurs. Due to this delocalization of charges, because of this bipoleron, this polymer become conducting in nature. So this kind of doping is known as N doping, in which the molecule carries negative charge. Another kind of doping is known as P doping. Another kind of doping is known as P doping. In P doping, oxidation process occurs, and oxidation is removal of electron. In P doping, oxidation process occur. Oxidation is known as removal of electron, and it is due to the presence of some Lewis acid. For example, if CHX is there, it reacts with FeCl3, 2 moles of FeCl3, and it will form CHX and FeCl3, FeCl4 minus, So this kind of doping is known as P doping, and due to delocalization of this positive charge. So again, I am taking the same molecule for showing P doping. If one electron is removed, as it is an oxidation process, one positive sign occurs and one free radical is formed. One positive sign occurs and one free radical is formed. Again, one more electron is removed and 2 positive signs are there. So it becomes bipoleron. Now the species is known as bipoleron. As positive sign is actually the deficiency of the electron. So these electrons get shifted towards this positive sign. Due to this shifting, actually this shifting is known as segregation of charges. Segregation of charges. So this is known as segregation of charges, in which the electron get attracted towards positive charge, and due to this segregation, in another unit of this thiophene, you can observe that the shifting of double bond is there. Due to this shifting, we can observe that there is a segregation of charges. So we can see that in N doping, negative sign comes on this molecule, and this delocalization of negative charge make this system conducting in nature. And in P doping, positive sign occur on the chain, and this delocalization of positive charge make this compound conducting in nature. So in N doping, reduction process occur, and in P doping, oxidation process occurs. Remember, in N doping, reduction process occur, in which positive sign is getting delocalized in overall chain. In P doping, positive sign is there, in which positive sign is delocalized in overall chain. Now, let us look at that what are the factors that affect the conductivity. So, what is the density of charge carrier? What is their mobility, the direction, the presence of doping material, what are the doping materials we are taking, and the temperature. There are some limitation of intrinsic conducting polymer, that it is having low conductivity, poor mechanical strength, poor storage ability, poor tolerance toward open environmental condition, especially temperature. So, these are the limitation of intrinsic conducting polymer. Now come to extrinsic conducting polymer. In extrinsic conducting polymer, there are two types. One is conducting element filled polymer. So, here polymer act as binder to hold the conducting element. What are the conducting elements we can take here? One is carbon black, another one is metallic fiber, another one is metallic oxide. So, this we can take as conducting element, and when we mix this conducting element to the polymer, it become conducting element filled polymer. And in hospitals, we are using these kind of conducting element filled polymer. Another one is blended conducting polymer. In this polymer, we are actually making polymer blend, in which we are taking any conventional polymer and mix this conventional polymer with conducting polymer. So, the polymeric chain become conducting in nature because conducting polymer is mixed with conventional polymer. So, this is known as blended conducting polymer. In both the type element filled conducting polymer and blended conducting polymer, in both the type mixing is occurring and the whole polymeric chain is actually not conducting in nature, just like in extrinsic conducting polymer. Now, coming to the last portion of my presentation is application of conducting polymer. So, nowadays these conducting polymers are useful in various systems such as rechargeable batteries, anti-static substances for photographic film, analytical sensor, making ion exchanger, corrosion inhibitor, compact capacitor, electrochromic displays, light emitted diode, laser used in flat televisions and solar cells. So, these are the applications of conducting material. So, here in this lecture we explained, studied about conducting polymer, types of conducting polymer and applications of conducting polymer. Thank you.